Hey, ninth graders, I am so terribly sorry that I can't be there with you again today. Um, Fingers crossed for quick healing. But we are going to wrap up the conversion lab that we started yesterday. Quick side note for those of you who handed me your conversion worksheets yesterday because you wanted me to check them, I did check those and they're on my desk to the left of the computer, kind of by a basket where I hold some papers. So if you want to check there, I did make some corrections and wrote on there what you could do differently. If you still want me to check your conversion worksheets, because remember you get to use that as a study guide, then just give it to me next time you see me, okay? So the conversion lab, you guys, we very quickly got started on it, but I want to walk you through this one more time. What we're doing here is relative measurement, and the idea I want you to understand behind this is what is relative measurement, why is it sometimes useful, and what are some of its limitations and downfalls. And then in doing this, we'll understand why it's so important in a lab setting, in a scientific setting, to use metric measurements that are accurate. Okay, so please make sure that you have your name and your hour 5, on this lab. And the first thing you're going to do is take just a regular ruler and you're going to measure the width of your thumb in centimeters. Remember, everything should be metric, and you're going to record it here. So basically all you need to do is put one side of your thumb um, at the 0 centimeters and measure how wide your thumb goes. And most people should have a thumb about 2 centimeters wide. Okay, so if you got something way different than that, you might want to try that again. Then what you're going to do is you're going to measure the width of your hand in centimeters and record it here. Most everyone's thumbs are about 2 centimeters wide, but when we start looking at hands, I know for a fact my hand is a lot smaller than some of your hands. So here we're going to start getting a little bit different, and there's a limitation, there's a downfall to relative measurement. So when I measured my hand, it was about 12 centimeters wide. Okay, so this might not be your same answer, and that's totally fine. Everyone's going to look a little different here. Reminder, now that I say that, is everyone is doing this on their own. You're using your own data, but you can still work with somebody, okay? So that you can ask each other questions as you go. Then what you're going to do is measure the length of your foot in centimeters. And when I measured mine, I got to be right around 30 centimeters. Okay, some people's feet are going to be much longer. Some people's feet might be shorter. Okay. Next, what you're going to do is you are going to use these measurements to predict. Remember, a prediction is a guess. Okay. So you're going to predict the length of the different objects in the room by using conversions. So the next step we'll use conversions, but here we're just going to predict. So what do you think the length of a piece of paper might be? Well, I happen to know off the top of my head that, and here's where like background knowledge is very helpful when we're doing science, right? You have to think about things the way that you know them and the way you see them. So I happen to know that a piece of paper, like a lab sheet, is 8.5 inches by 11 inches. And this says length, so I want to know how long the piece of paper is, okay? I also know that Mrs. Wire gave me a handy dandy conversion sheet from standard to metric in my lab book, and there's about 2.5 centimeters for every inch, okay? So if the length of a piece of paper is 11 inches, and I know that there's about 2.5 inches in every about 2.5 centimeters in every inch, I can literally just multiply those two from the conversions that we did yesterday. So remember, let's just say that length of a piece of paper is 11 inches. Okay, and I want to get to centimeters. And again, this is just a prediction. This is based off of something I know and from prior knowledge. And I know that I want to get rid of inches, so in every 1 inch, I'm putting it on the bottom, because remember up here it's on the top. It's the same as putting this over 1. So I want to be able to get rid of inches, 1 on the top, 1 on the bottom. For every 1 inch, here's my conversion ratio, there's 2.5 centimeters. Okay, so if I do my math correctly, 11 times 2.5 is going to be about 27, okay, or we could even say 28 centimeters, okay. So I'm going to say the length of a piece of paper is maybe about 28 centimeters. I didn't measure it at all. That was just a guess, okay. I can do the same for a height of a lab table, and I can do the same for a length of a lab table. You might think that the height of a lab table is maybe around a meter stick. Okay, so I'm just predicting the length of a lab table might be 1.5 meter sticks or something like that. So I could go ahead, oops, I forgot to put my units here, and just make those predictions. Okay, now what I'm going to do is I'm going to use what I measured over here. So this is the relative measurement. And I am going to try to figure out the relative length of a piece of paper. So I'm going to do number 1 with you, and then you'll do 2, 3, and 4 on your own. So the important piece is you are predicting first. Okay, so how many thumbs long is your paper? Well, my prediction back here was about 28 centimeters. Okay, so we're going to say that it was about 28 centimeters. Okay, and I want to know how many thumbs long. So now I have to figure out my conversion ratio, and I get that from right here, what I already measured. So what is the width of your thumb? 2 centimeters. So for every, 1 thumb, and I want thumb on top, I'm just going to do thumb as a T, so I don't have to write it all out. For every 1 thumb, it's 2 centimeters. Okay, so this is on the top because that's the same as 28 over 1. I have centimeters on the top, centimeters on the bottom. They cancel out. So I need to divide, okay, because this is on the bottom, this is on the top, so I'm going to divide 28 by 2, and that's going to give me a prediction of about 14 thumbs. Now what I want to do is I'm going to actually measure my paper in thumbs. Okay, I'm going to measure my paper in thumbs. So you're going to take your thumb and your other thumb and then next, and you're going to count as you walk down the paper lengthwise with your thumbs. And as I do that, my total number of thumbs was 15. Now, yours might be a little different. Your prediction might have been a little bit different if you didn't use the same background knowledge as I did. But then you're going to answer, was the total close to your prediction? Yeah, mine ended up being relatively close to my prediction. Okay, 1 centimeter off. I should say 1 thumb off. Okay, now you're going to do your prediction. How many hands high is the lab table? So you take your prediction from over here. Height of lab table, however many meters or centimeters you think that might be. Please remember you measured these in centimeters, so if you did this in meters, you might need to convert that. Okay, you got to make sure your units are the same. So you're going to write your prediction here, and you're going to figure out your conversion ratio, and then figure out the hands. Then you can measure it with your actual hand, and then you can tell me if your prediction was close. You'll do the same thing for 3 and for 4 using your predictions from the length of the room, which is given to you, luckies, and the length of the table. Okay? All right. Then what you're going to do is you're going to answer questions 5 and 6. 5 and 6 are conversion questions. All right? So this, if you need help on 5 and 6, you should go back to the worksheet that you did yesterday and you should set these up. So step 1 is how are your units related? Okay. So we have a hand that's 10 centimeters wide. We're trying to figure out how many hands high that flagpole would be. And then step 2, find your conversion ratio. Okay. And then what you're going to do is calculate it out. Same thing for 8. 7. Or excuse me, same thing for 6. 7 is, and I don't do this very often, but 7 is extra credit. If you can figure out this, the answer to this question, and it's going to look kind of crazy, I will give you 3 points of extra credit. So that's 3 like test questions. Okay, 3 points of extra credit if you can figure out number 7. And when I collect these, if it's correct, I will give you those 3 points extra credit, which is a big deal when a lab isn't a whole lot of points. Okay, if you get done early with this, what you're going to do is you're going to write a conclusion. And your conclusion is going to be a paragraph. And remember, a paragraph is about 5 sentences. If you have this modified, then you get to write 2 to 3 sentences. And what I want you to describe is what is the usefulness of relative measurement. So using an object that you know how big it is to measure something else. So what is the usefulness of that? And what are its limitations? Okay, so that's 2 sentences right there. Why is it useful? Relative measurement, but what are its limits? And then the other 2 to 3 sentences is going to be explaining why you think it's critical in a science classroom laboratory setting to measure using the metric system accurately. Okay, so that should be what your conclusion is. 1 to 2 sentences on why relative measurement is useful, but what are its limitations? What are some problems you see with it? And then the last 2 to 3 sentences, why do you think in a science classroom it's important to have accurate metric measurements? All right. I want you to hold on to this if you're totally done until I return, and we will turn it in at that point. Have an awesome day.